Hello, everyone. My name is Manish Srinivasan. I'm doing the short video today to give an orientation on the various math Olympiads. I've done 2 or 3 interactive sessions with students on this topic, but for wider reach, I thought I'll do a recording and share it along. So without further ado, let me just share my screen here. Yeah, this should not take more than like 10 or 15 minutes, I'm hoping. So competitive math exams and Olympiads, an introduction. My name is again Manish Srinivasan. First, I'll just do a quick introduction about myself. Then we'll cover why we do competitive math and what does it take to excel in competitive math. What are the different topics that are covered and what's the toolkit you need to equip yourself with to excel in competitive math. What are the popular exams? Broadly, we can say 3 categories: Asian, Canadian, American. There are a bunch of Asian Olympiads. There are a few of the Canadian ones, and American AMCs are only few, but those are the most popular ones. And then we look at a few sample questions and what the exam formats of these different tests look like approximately. Okay, so first introduction. My name is Manish Srinivasan. I did my BTech back in the mid-90s from IIT Madras. Went on to do my master's in computer engineering from UT Austin. Worked in the US for about 12 years. So in between, I did another master's in computational finance, also known as financial engineering. I've been working in Wall Street firms ever since. I continue to do so. And teaching is my part-time passion, I would say. So I started way back in 2001 with Kaplan and Princeton Review, and then soon spun off on my own. I started teaching on my own. And then once I moved back to India in 2010, I'd been teaching in various Mumbai locations. Post-COVID, everything has now shifted to Zoom. So it's location agnostic now. I have students from a lot of places. So I'm proud to say I've tutored about 800 plus students in my career. And I'm also very glad to share that many of them have ended up in top ranking schools, no less than MITs and Stanfords and Caltechs. And the students that I've trained have been mostly from the popular Mumbai schools, Dhirubhai, Abha, Cathedral, American, JNS, Oberoi, Singapore, Podar, BD Somani, HFS. And then ever since the Zoom model started, I've had students from other cities and countries as well. So what do I focus on? Over the last decade, my focus area also has changed. These days, I focus mostly on the competitive math, in particular the AMCs, the Canadian Olympiads, and the Asian Olympiads. I also have started teaching for UK MT and the Australian Olympiads, but I also do teach occasionally for JEE mains, and in the past I've done for ACTs and SATs and AP Calcs and GREs and GMATs, although these are few and far between these days. I also focus on school curriculum, mostly on IB and A levels. And this is my coordinates. You can reach me in any of these locations. Okay, so why do we do competitive math? Basically to develop your analytical skills. So a bunch of reasons. The main thing for me, it's very interesting and challenging, right? You hone your analytical skills and helps you improve speed, accuracy, and estimation. All 3 are different dimensions and all 3 are important: speed, accuracy, and estimation. You're able to connect or relate to other subjects. Physics, economics, statistics are popular subjects which have a close tie with math. And then some of you might genuinely love math, some of you might be borderline, but trust me, once you start doing such challenging problems as competitive math exams offer, you'll genuinely fall in love with math and problem solving in general. And then school curriculum becomes so much more easier once you're used to some of the harder questions that these exams offer. It also strengthens your STEM profile. So students looking to apply for top STEM colleges definitely stand to benefit by putting your accomplishments on your resume with respect to achieving in these competitive exams. Okay, what are the topics? the core topics are algebra, arithmetic, sequences and series. By sequence series, I mean arithmetic progression, geometric progression, harmonic progression, all that. By algebra, it's a wide collection, right? Ranging from your numbers classification to rational, irrational versus the common algebra, as we all know and we have done in our childhood. And then commercial math, rates and speed, direct proportion, indirect proportion, all of these basic concepts, but some of the questions can be really interesting with them. Various types of geometry, 2D, 3D, coordinate geometry, combinatorics, which is a combination of, which is a mix of permutation and combination. Permutation is arrangement, combination is choosing. So all of that falls under combinatorics. And then there's probability and statistics. And then over the last decade or so, number theory has really taken off. Very interesting questions in number theory. Logic and symmetry, which is like not even too much of math in it. It's just plain logic. So a lot of questions on logic and symmetry, and then sets and functions, which arguably is part of algebra. So sets and functions, and these are the core topics. Now there are also some advanced topics. By advanced, what I mean is some competitions test them at the 9th and 10th grade itself, and others test them only in the 11th and 12th exams. The competitive exams are for different grades. Now, some of them, especially the Asian ones, don't hesitate to ask some of these questions in trigonometry and logarithms, even as early as the 9th and 10th grade. So there's trigonometry, there's complex numbers, logarithms, binomial expansion. Calculus is not needed, but quite useful, especially for 11th and 12th graders, since you would have done some basic calculus already. There are questions which can be easily solved using calculus, but obviously there'll be an alternative solution which you don't need calculus, but why go with a longer solution when an easy solution is an option, right? So calculus is also a useful tool for, especially for 11th and 12th graders. Okay, so those are the topics. Toolkit. So toolkit, what all do you need essentially, right? You need to be good in estimation and elimination. Intelligent elimination, not random elimination, but intelligent elimination. You need to develop the art of sense checking or sanity checking, as I like to call. So checking for some very basic base cases. Let's say you come up with some general formula. You want to test it for at least for some small numbers, right? That's base case testing. And then testing for edge cases. So again, I'm talking very abstractly here. You push it to one particular extreme, and if that formula works for that particular edge case. And then units and dimensionality check. So I'll just quickly illustrate this with an ellipse example, but essentially, if the question is asking for a length, and if the answer choice you're marking is actually an area, it's surely going to be wrong. So a basic check on dimensionality is extremely important. You should be able to simplify a lot of problems using symmetry. So that's another useful skill to pick up. And then this one, recognizing numbers, I'll touch on it in the next slide. Squares, cubes, powers, primes, and patterns. I'll touch on it in the next slide, what I mean by recognizing numbers. And then there's always a balance between speed and accuracy. We touched on it earlier. Each of these two is a separate dimension in itself, but there's always trade-off. You don't have infinite time, so you'll have to go fast, and you should not compromise on accuracy either. So it's a balancing act. Okay. So what is this illustration I had here with an ellipse? So for example, for people who don't know the area of an ellipse, and suppose you're asked, what is the area of an ellipse? You can still pick the right choice by making some wise eliminations. Okay, so what are those? So in the extreme case, when A becomes B, so A and B here are the semi-major and semi-minor axis of an ellipse. As you can see, even if you don't know the terminology, you can sort of feel it, right? There are two different radii. You have a big radius and a small radius, as opposed to a circle having just one radius. So A and B are like, you can think of them as two different radii. Now, in the extreme case, if A becomes B, A becomes equal to B, then it becomes a circle. And we all know the area of a circle is pi r square. So if I put A equal to B, the answer I'm expecting should be pi r square. Now, the very first option here is pi into r square plus r square, which is obviously wrong, which is because it gives 2 pi r square. So A is eliminated because of that simple reason. B is still in contention. So pi into r square plus r square by 2 is pi r square, which is what we need. C is also in contention, pi into r into r. D is also in contention. R cubed by R is R square. So pi R square. E can be eliminated because we're getting pi into 2R cubed. First of all, forget the 2. We are getting an R cube, which is a volume. How can a volume be an answer for an area? So just by pure dimensional check, I can eliminate E. Okay, so what remains in contention is now B, C, and D. Now D can be eliminated because it's not symmetric in A and B. Now tomorrow if I go and mix A and B, I label the longer one as B and the shorter one as A. My answer for the area of the ellipse should not change. We expect some sort of symmetry between A and B in the resulting expression. But here it's not the case, right? A cubed by B is not symmetric, right? It has some priority towards A. A is in the numerator and A has a power of 3, whereas B is in the denominator. It has a power of 1. I cannot swap A and B and make a same expression, right? That's what symmetry is all about. So I can eliminate D. Now that leaves us with B and C. So B and C are both areas because you have A into B in choice C, which is an area. And then in choice B, we have A square plus B square. So which is area plus area, which is an area, right? So dimensionally we pass. If you put A equal to B, we get the expected pi R square. So that also passes. Now, what else can we do? We can drive the ellipse to the other extreme. Instead of making it a perfect circle, we can squish it and make it a flat line. In that case, B approaches 0. The ellipse just collapses to become a small, a very thin ellipse, if you will, almost like a flat line. So for a line, we know the area is 0. There's no area at all, right? So the expression, when you put B equal to 0, must evaluate to 0. Now, choice C does that. Pi into A into 0 becomes 0, whereas choice B does not do that because it becomes pi into A square by 2. Therefore, choice C is the right one that we can pick. Now, this is obviously you're not going to get many examples like this where by different means you can eliminate all the choices, but just a simple illustration to show that without knowing an answer, we can still find reasons to eliminate some of the wrong choices. Okay, so that's the sanity checking bit I wanted to cover. Okay, this slide talks just a diagrammatic view of all the topics, right? We touched on it: algebra, coordinate geometry, logic, symmetry, number theory, 3D geometry, permutation, combination, probability, all of that. And the advanced topics, you have trigonometry, logarithms, complex numbers, all of that. Okay, so obviously if you have complex numbers or logarithms or trigonometry at a 9th or 10th grade level, they're not going to push you very hard, but at least basic exposure is needed. For AMCs, you don't need that, but for Asian Olympiads, they do check. Okay, now recognizing numbers is a very important skill. So what I mean here is, if you're asked what is 3 power 5, then anyone can tell you it's 243. It doesn't take too long. But the reverse process is also important. If you come across 243, you should recognize it's 3 power 5. And the skill is important because to solve problems, if you're able to make that connection, it gives you a good clue into the next step. Recognizing that 243 is 3 power 5, recognizing that 4096 is a power of 2, right? It's 8 power 4 or 2 power 12, whatever it is. As long as you recognize it's in the family of powers of 2, that's good enough. Recognizing that 961 is a perfect square. Recognizing that 2520 is an LCM of 1 to 10. Recognizing 1729 as the famous Ramanujam number, the smallest number that can be expressed as sum of 2 different cubes in 2 different ways. So 12 cube plus 1 cube, 10 cube plus 9 cube. So like this, recognizing numbers is extremely important. I'm not asking like till like 20 digits or something, right? At least very basic till 1000. You should know all your perfect squares, perfect cubes, and powers, and prime numbers at least till 200 or 300, I would say, right? Or even arguably even till 1000. Because it does not take too much to figure out a number is prime or not. For example, to test if a number like 899 is prime or not, you only need to check till the square root of 899, which approximately is 30, right? And even there, you only need to check divisibility by prime numbers until the square root of the number. So literally, we are checking 2, 3, 5, 7, all the way till 29. to check if 899 is prime or not, which by the way, it's not, because 899 is 900 minus 1, which by a square minus b square becomes 30 square minus 1 square. And therefore, it's 29 into 31. So it is divisible by 29 and 31. So you have to go all the way till 29. You cannot just stop checking till 17 or 19 and find no divisibility and just conclude it's a prime. So we should still go till the square root, but it's still a much smaller set of numbers you have to check divisibility with. Okay, so recognizing numbers. Now, next one is what are the different different Olympiads that we have, right? Asian Olympiads, they have just run amok. There are so many of them. A word of this thing first, right? So you don't have to go crazy and write every single one of them. I've mentioned this later in the slide also. Maybe you can give like 3 or 4 of them. There are at least 15, 16 of them. WMI, SIMSO, GJMAT, AIM, HKIMO, GJ Mock is an advanced version of GJMAT. There's Philippines, Philippines, which is PIMSO. There's ASMO, CMO, team. You can read it, right? So these are the main. I hope I'm not missing anything, but I could very well be missing 1 or 2. But definitely these are the popular ones. And the Canadian Olympiads are fewer by comparison. They have 1 for each grade. For Pascal, Cayley, and Fermat are the 9th, 10th, and 11th equivalent exams. And then there's Fryer, Galois, and Hypatia. The reason I've put them as 2 different columns is the left column is all, MCQ and just free-formed response. Whereas the right one, the Fryer, Galois, and Hypatia, you have to write some descriptive answers. It's also free-formed, but on top of free-formed, it's not just a single answer. They will also ask you to describe or prove. Such problems are also there in Canadian Olympiads. And then American Olympiads, this I think there's a lot of awareness. AMC 8, AMC 10, and AMC 12. Each of these can be taken at a grade which is less than or equal to that particular number, right? So you can be a genius and you can be in 6th grade and write AMC 12, for example, right? Or be in 2nd grade and write AMC 8, but you cannot be in 9th grade and write AMC 8. But typically it's 7th and 8th graders giving AMC 8, likewise 9th and 10th graders giving AMC 10, 11th and 12th graders giving AMC 12. AMC 10 and 12 are generally in November. AMC 8 alone is in January. Again, a lot of this has changed over the last few years around COVID time, but it's more or less stabilized into these dates now. And Australian Olympiads is also offered, I believe, around July, around that time. Okay, and this is the calendar for 9th, 10th, and 11th and 12th graders. I'll be sharing this PDF along, but I thought I'll just quickly walk you through. Like I said, Pascal, Cayley, and Fermat are the exams which are only MCQs or very short free-formed responses. And the other ones are more expanded answers. The registration dates on these are not final yet. I've just approximately taken 1 month prior to the exam date. The exam dates are definitely confirmed. The registration dates are not confirmed. The exam fees also, they're not much. All of these competitive math are in the range of 1,000 to 1,500. The only exception is GJ Mock, and where to its precursor, which is GJ Mat. If you do well in that, you get a substantially discounted rate, depending on how well you do in GJ Mat. Okay, but other than that, all these other exams, the application fee is only in the range of 1,000 to 1,500 on an average, right? Okay, so that's CMC, the Asian Olympiads. I've listed literally all of them that I talked about. Most of them are like 1 per grade. So, for example, WMI, there's 1 for 8th grade, 1 for 9th grade, 1 for 10th grade, and so on. But some of these exams, they combine a couple of grades. Now, I've just literally copy pasted and written for each grade, because for the most part, that's the case. But there might be a couple of them where 9th and 10th are combined into one, 11th and 12th are combined into another, and similarly, like 7th and 8th into another, right? So, but it's still very much reachable distance, right? It's not like they're combining 7th, 8th, and 9th, when it becomes very unfair for the 7th graders. So 9th and 10th is fairly doable, right? And then the AMCs, as we talked about, those are in November and January. November is AMC 10 and 12, and AMC 8 is in January. Okay, what to appear in? AMCs and CMCs, highly recommended. I would recommend you to appear in all of them. All of them meaning let's say you are in 9th or 10th grade, you can only appear for AMC 10. And then the CMCs, you literally have a couple of them depending on which grade you are in. So let's say you're in a 9th grade, you can write Pascal and Fryer. Yeah, you can actually write the higher exam. Saying in 9th grade, you can also write Cayley. But if you write Cayley in that year, you cannot write Pascal. So you have to take a choice. If you want to take a bet and you think you're really good, you want to show that, you can be in a 9th grade and you can be in 9th grade and write Cayley and Galois, but you cannot write Pascal along with Cayley. Okay, that restriction is there. So literally we are talking about 2 exams in CEMC and 1 exam in AMC in a particular year. Now, the Asian Olympiads, like I said, there are about 14 or 15 of them. You can write maybe 3 or 4. That should give you a selection of 3 or 4, should give you good coverage and diversity to the resume, saying I've done this, this, and this Asian Olympiads. Now, all of the Asian Olympiads have a second level as well, where you're required to travel. Not many people like to do that, but the first level is all online. So there's no reason why you should not appear the first level. And even that score itself is good enough to put on your resume if you're looking at from a application perspective. Okay, calculators are not allowed at all in AMCs and Asian Olympiads. They are allowed partly in the Canadian Olympiads. And the exam format, AMC is very clear. It's only MCQs, objective multiple choice question. Asian Olympiads is a mix of MCQs and free response. And CMC, we touched on it, MCQs and free response. And even within free response, I can categorize as 2 cases, right? One where you just write one answer. There's no guessing. You have to write an answer, or it could be prove that or show that. It could be more descriptive as well. So that's CMC. And then these are some sample questions I've picked from some of the Asian Olympiads just to give some flavor, right? You have all this irrational numbers, you have functions, and then here you have something on circles, like on geometry, and then here's something on logarithms, something on trigonometry. I just picked a random few questions just to give a flavor. Okay, so that's about it. Hope this was useful. And then I'll see you in some other video.